Hey, welcome back. So what I've done so far is built this and soldered 2450. I think this comes out to 2480 ohms or 2.48 kilo ohms resistor. You need to solder this across the antenna line to the ground. So I've done that. I've also added a capacitor here. And now let's read the signals in read the values in nano VNA. So I've got a calibrated nano VNA. I'm plugging in the, okay, as you can see, let me push this way so that we can focus on the nano VNA a little bit. And as you can see, I've configured this for 3 megahertz to 30 megahertz. And if you can see at 7 megahertz, where are we? Now we are at 7 point. In India, the band for 40 meters is 7 to 7.2 megahertz. It is not 7.3. So I'll focus on 7.1 megahertz. So for 7.1 megahertz, I'm getting 1.4 SWR, and then for 14200, I'm getting 1.7. I mean, don't take this. If the winding is correct, 2 primary and we have 12 secondary, and if you put a 19.5 meter antenna radial, 2.5 square mm or even 4 square mm, it will be a little lesser than 19.5 meters, probably 19.2 or 3 meters. You will get less than 1.3 across all the 4 bands, 40, 20, 15 and 10. So this is just an indicator with nano VNA and connecting to 450. Is the winding all correct, and we can put it in the box. That's all, nothing more than that. So for 18.052, 18.120, which is fairly good, we have got 1.8, and for 21 ones 237, I've got 2, and it's varying. As you can see, it's varies based on what's happening here. And at 10 meters, I have it. Let me switch on the scale, show grid values. Yeah. So as you can see at 28.3, it's somewhere around 2.7 SWR. So this is just an indicative value, just to see that your connections are all right. That's all. I mean, it looks good actually. So this is how you test your toroid after winding. Let's look at the winding again and the connections. I'll keep the nano VNA aside, and let's go over the winding once more. Okay, so what we have here is the winding, and you can adjust the winding a little bit. And like you have seen, I've already tied up the winding with one single cable tie, and the dual pair, the primary goes to the ground. The what comes out of the primary, the single one goes into the core of SO239. Yeah, SO239. And then we have the capacitor going from the core to the ground. Remember, we don't have a output for counterpoise. I'm not using that because it's usually I have not used it. I don't see a need. As long as you put RG58 and a thicker cable, you're fine. You don't need a counterpoise, right? So this is the ground, and this resistor you want to use this only for testing purposes. This lead goes into the antenna side of things. Okay, so this is testing. It looks fine to me. I'll go ahead and clean up everything up, and we'll put it in the box, and I'll come back once I've put it in the box. Back. Thank you. So I've managed to put this together. Yeah, soldering is putting this together is a pain because of the box size. It's very, very small, and I probably need to get a little bigger one. This is like I mentioned, 70 by 70 by 50, maybe 80 by 80 by 50 would be fine, or 60. I need to check if I can get such boxes, but right now this is working fine. I can still make it work, and it's very compact for the field operation. It's excellent, very, very compact. I'll just tighten this a little bit. Yeah, that's tight enough. Okay, so here it is, the finished one. Thank you very much for watching this. Hope this will help you making your own fatty toroid in-fed half-wave antenna, and best of luck. 73, and catch you all down the log. Thank you very much. Have a great night. 73 again. Bye.